Hi, and welcome to Chapter 7.1. We are going to start talking about chemical reactions. Now, a long time ago, we discussed things like chemical properties and physical properties. Physical properties are things like color, shape, size, mass, things like that. Chemical properties are things that have to do with compounds or elements undergoing chemical reactions. So, evidence for chemical reactions are things like a change in color, the production of a gas or bubbles, or the formation of a precipitate. And remember, a precipitate is when a solid comes out of two or more liquids that are mixed together. So, whenever we see evidence of a chemical change, that means a chemical reaction is going on. And we can describe that chemical reaction using a chemical equation. So chemical equations are an easy way to describe a chemical change and what is present before the change and after it. So this is a visual example of a chemical equation. We have a CH4 molecule and two oxygen molecules, and when those come together, they undergo a chemical reaction and they end up changing from CH4 and O2 into CO2 and H2O. Now, when we write chemical reactions, we're not going to draw the molecules out. We're actually going to write out the formulas, whether it's a covalent molecule or an ionic compound. We're going to write out the formulas. Now, the substances found on this side of the equation are called the reactants. This is what we start with. So in this sample equation, our reactants are CH4 and O2. The parts on the other side of the arrow, over here on the right side, these are called the products, and that's what we end up with after the chemical reaction happens. So in our sample, our reactants, or our products here, are CO2 and H2O. And chemical equations not only tell us what products we get, so do we get carbon dioxide or do we get oxygen, it also tells us how much we get of each thing. And that happens by using coefficients. Now, if you look at our sample equation here, the number 2 in front of oxygen right here is called a coefficient. That's telling us we have 2 of these O2 molecules. And the only way that this reaction can work is if we have 2 of them. If we only have 1, the math doesn't work out and we don't have enough atoms to go around to actually make this reaction happen. Now, that is all based on something called the law of conservation of mass. And the law of conservation of mass tells us mass is neither created nor destroyed. Basically, you can't just make an atom out of nothing, and you can't just destroy it either. Whatever you have to start with, you have to end with. It may take a new form, but everything you start with has to be there in the end. For example, if we take a look at carbon reacting with oxygen to make carbon dioxide, we have 1 carbon atom on our reactant side and 1 oxygen diatomic molecule on our reactant side. And over here we have carbon dioxide. Now, these gases have changed into a new form. A chemical reaction has happened where they've changed from one formula into another. But the number of carbon atoms we started with is the same as the number of carbon atoms we end with. Same with oxygen. So if we take a look at this equation, we have 1 carbon atom here, and we have 1 carbon atom here. The subscript on oxygen tells us that we have 2 oxygen atoms on this side, and we have 2 oxygen atoms on this side. So what we started with is what we end with, always. Now, in order to make sure that a chemical equation is truly upholding the law of conservation of mass, we need to make sure it's balanced. This means the total number of an element on the reactant side has to equal the total number of an element on the product side. And we can do that using coefficients. And remember, coefficients are the number in front of an element or a compound. So if I have H2O, this right here is a subscript. This is telling me that in a water molecule, I have 2 hydrogen atoms and 1 oxygen atom. But if I have 2 water molecules, I would write that as 2H2O. This 2 in front is the coefficient, and that's telling me that I have 2 of this entire thing all together. So let's take a look at how we would actively balance an equation. This is the example I did a couple slides ago, where we have carbon and oxygen reacting to make carbon dioxide. And I'm going to use this because we really don't have any balancing to do, we just have some checking. So the first thing you want to do whenever you're trying to balance an equation is you want to identify what elements you have on both sides of your equation. So if we look at our reactant side, so we're looking at everything to the left, we have 2 elements. We have carbon and we have oxygen. If we now look at the product side, everything to the right, we have carbon and oxygen. Now if we count how many of each thing we have, over on the reactant side I have 1 carbon atom and I have 2 oxygen atoms. Over on the product side I have 1 carbon atom and 2 oxygen atoms. So now if I look at each individual atom and how many I have on my reactant side compared to my product side, these need to be equal. And if they are equal for everything, not just one element, but for everything, this is a balanced equation. Now let's take a look at something that's not balanced and figure out how to balance it. So again, our first step is to identify the elements on both sides of our equation. So over here we have hydrogen and we have oxygen. These are our 2 reactants. On our product side we have hydrogen and we have oxygen. Now over on our reactant side I have H2, which means I have an atom that has 2 hydrogen atoms in it. And over here I have O2, which means I have 2 oxygen atoms. Now if I look at my product side, I have 2 hydrogen atoms. That's what the 2 in H2O means, 2 hydrogens. And I have 1 oxygen atom. So while hydrogen might be equal, oxygen is not equal, which means we have some work to do to balance these out. So the first thing you want to do is do the most basic thing you can think of to try and balance the unbalanced portions. So oxygen has 2 on the reactant side and 1 on the product side. So the easiest way to change that and make them equal is to put a coefficient in front of H2O in order to make the number of oxygens on this side match this side. So if I want the number of oxygens on this side to match this side, which is 2, my coefficient has to be 2. So now what happens is I have to erase and recount the number of each atom on this side of my equation because I've now added a coefficient. And that coefficient not just applies to oxygen, it also applies to hydrogen. Now, we can't add a subscript like this because then that's making a chemical bond. We are forcing an extra oxygen atom to bond here, which is not a good thing. It doesn't happen that way. So the only way we can balance equations is by adding coefficients, which means we're changing the number of total sets, total compounds. So now if I recount, I have 2 oxygens because I have 1 oxygen in one water molecule and another oxygen in the other one. And I have 4 hydrogens. There are 2 hydrogens in each molecule. 2 of those molecules means 2 times 2 is 4. So now if you look, our oxygens are balanced, but our hydrogens aren't balanced. So now we need to go over to this side and figure out how to change this side in order to balance the hydrogens. If we look at this side, we have 2 hydrogens, and on this side we have 4. So in order to get this to go to 4, I have 2 in my molecule here. I need to add a coefficient of 2. Because if I have 2 of those atoms in one molecule, that means if I have 2 of the molecules, I have 2 times 2, which is 4. So now I look at my total numbers, and right now I have 4 oxygens on my 4 hydrogens on my reactant side. Sorry, 4 hydrogens on my reactant side and 4 hydrogens on my product side, so those are equal. 2 oxygens on my reactant side and 2 oxygens on my product side, so those are equal. So we are done. Now I have a third example here And what I'd like you to do is to pause the video and try and do this one on your own. You will have to do a couple of these for homework, but try and practice this out, and then I'll show you how to do it. Did you pause the video? I hope so. I'm going to go ahead and balance this out for you so you can see how this works. First thing is we need to write down all of the elements on each side of the equation. So we have nitrogen, we have hydrogen, and we have oxygen. And then we need to count how many of each we have. So we have 2 nitrogens, 4 hydrogens, and 2 oxygens. On the reactant side, we have 2 nitrogens, 2 hydrogens, and 1 oxygen on the product side. Now, we need twice the number of hydrogens on our product side, and we need twice the number of oxygens. And that's really convenient because hydrogen and oxygen are bound together. So in order to go from 2 hydrogens to 4, I need to add a coefficient in front of water of 2. Because now I have 2 times 2 is 4 total hydrogens. But I also need to reevaluate my oxygens. I have 2 times 1 is 2 oxygens. So now if I go through and I double check, nitrogens are equal, hydrogens are equal, oxygens are equal. This is now a balanced equation. So when you write this equation out, in order for it to be truly balanced, you would write N2H4 plus O2 goes to N2 plus 2 H2O. So now that we've seen what a chemical equation is and how to balance them, please complete these homework questions and have them ready to turn in tomorrow.